Hi, I'm Dimitris Haralambidis, and in this presentation we'll talk about conversions between degrees and radians. We'll start by defining 1 degree and 1 radian. A unit of 1 degree is defined as the measurement of an angle that is equal to the 1 over 360 of a full angle. On the other hand, a unit of 1 radian, otherwise known as rad, is defined as the measurement of a central angle theta of a circle that corresponds to an arc S of the circle that has exactly the same length as the radius of the circle. Since both degrees and radians measure angles, we are thinking that maybe there is a relation between them, and if there is, there might be a way of converting degrees into radians and vice versa. To answer that, we will need a circle with a radius of 1. In such a circle, the full angle theta of 360 degrees, if measured in radians, will be equal to the length of the circle's arc that corresponds in that angle. In this case, that arc will actually be the whole circle, and its length can be found by applying the formula 2 times pi times r, which in our case is equal to 2 pi times 1 equals 2 pi. Thus, we can get that the 360 degrees are equal in 2 pi radians. Having that in mind, we can also create the following proportion. If 360 degrees correspond to 2 pi radians, then μ degrees, where μ is a random number, corresponds to A radians, where again A is another random number. And that proportion can give us the relation we were looking for. So, we should write that 360 over μ equals 2 pi over A, which, after some basic operations, can be written as A over μ equals pi over 180. We can also remember that radians over degrees equals pi over 180. Let's now see some examples. First example, convert 60 degrees to radians. What we will do is apply the previous formula for μ equals 60, since we were given an angle in degrees, and then we will solve for A. So, we start by writing A over μ equals P pi over 180. Thus, A over 60 equals pi over 180. Thus, A equals pi over 180 times 60. Thus, A equals pi over 3. Hence, 60 degrees, if measured in radians, are equal to pi over 3 rad. Second example, convert pi over 4 radians in degrees. Again, we will use the previous formula, but this time we will substitute pi over 4 in place of A, since we were given an angle in radians, and after that we will solve for μ, since μ represents the degrees of the angle. So, we begin by writing A over μ equals pi over 180. Thus, pi over 4 over μ equals pi over 180. Then we do a cross multiplication and write pi over 4 times 180 equals pi times μ. Both pi's can be cancelled out, and we can write 180 over 4 equals μ. Thus, μ equals 45. And this means that pi over 4 radians actually correspond to 45 degrees. For any questions about this presentation, you can leave comments down below, or you can contact me with one of the following ways. As always, thank you for your time.